All right, let's talk about something every single person who's ever written Python has stared at. Those bright red error messages. You know the ones. But what if they weren't roadblocks? What if they were actually roadmaps? Today we're going to dive in and figure out how to turn those frustrating errors into a source of real power. Ah, yes, this old friend, the infamous name error. If you've written even a few lines of Python, this probably looks painfully familiar. And it's so easy to see this wall of text and just think, oh, I messed up. But here's the thing. You haven't. This isn't failure. This is just Python trying to talk to you. It's a clue and a puzzle, and by the end of this, you're going to have the decoder ring. So here's our roadmap for today. We're going to start by totally reframing how we look at that red text. Then we'll build up a solid foundation, talking about Python's data, a super important concept called mutability, and why making your code easy to read is a big deal. Then we'll use all that new knowledge to decode common errors and unlock your new coding superpower. First things first, let's change our perspective. Those error messages, they aren't dead ends, they're signposts. Python is literally telling us exactly where things went sideways and why. We just need to learn how to read the signs. Okay, so to understand the clues Python is giving us, we've got to go back to square one. It all starts with how Python thinks about data. This is the bedrock for everything else we're going to build. So what is a variable, really? The best way to think about it is like a label you stick on a box. The variable isn't the data itself. It's just a name, a label, that points to a piece of data living somewhere in your computer's memory. And this is a really key idea. The variable is the label, not what's in the box. And what kind of stuff can these labels point to? Well, all sorts of things. The most common ones you'll see are integers for whole numbers, floats for numbers with decimals, strings for any kind of text, booleans, which are just a simple true or false, and lists, which are basically just ordered collections of other things. Each of these types has its own rules for what you can do with it. Now, here's where Python starts to feel a little bit magical. It uses something called dynamic typing. See, in some other languages, you have to tell the computer ahead of time, hey, this variable is always going to be a number. But not Python. Python is smart. It just figures it out on the fly while the code is running, and that makes it incredibly flexible. For instance, look at this. We assign the number 42 to the label x. Python immediately sees it's a whole number and says, okay, the type of x is now an integer. We didn't have to do anything extra. But check this out. We can take that exact same label, x, and immediately tell it to point to a string of text instead. Python doesn't get confused. It just moves the label. And boom, just like that, the type of x has changed from an integer to a string. This dynamic power is amazing, but it's also why this next idea is so incredibly important to understand. This brings us to what might be the single most important concept for avoiding weird bugs in Python. It's the hidden rule of mutability. For a lot of people, when this clicks, it's a total aha moment. So here's the deal. Every single piece of data in Python is one of two things. It's either mutable or immutable. Immutable means that once it's created, it can never, ever be changed. Anytime you think you're changing it, you're actually creating a brand new object. Mutable, on the other hand, means you can change it directly, right there in place. Lists are the classic example of something that's mutable. So our label myList is pointing to a list object. When we use the .append method, we are literally reaching into that original list object and adding something to it. We didn't create a new list, we just changed the one we already had. Now, let's compare that to an immutable string. When we add an exclamation mark here, it really looks like we changed my string, but we didn't. What really happened under the hood is that Python created a completely new string, hello, and then just moved our myString label to point at that new thing. The original hello is still floating around, completely untouched. Getting this difference is the key to dodging so many headaches. Okay, we've covered how the computer thinks about our data, but that's only half the story. What about us, the humans? We also need to agree on some conventions to help each other understand what we're writing. The creator of Python, Guido van Rossum, said it best right here. This is the entire philosophy behind Python's official style guide, PEP 8. The point isn't just to write code that works. The point is to write code that's clear and easy for other people, and you, 6 months from now, to actually read and understand. Readability really, really counts. So what does that look like? Well, PEP 8 suggests a few really simple naming rules. For our variables and our functions, we use snake_case, That's all lowercase with underscores between words. For classes, we use cap words, sometimes called Pascal case. And for constants, variables whose values should never ever change, we just use all uppercase. Following these simple rules makes your code instantly easier to scan and understand. All right, we've built our foundation. We know variables are labels, we get dynamic typing, we understand the critical difference between mutable and immutable, and we know why style matters. So now, let's use that knowledge and go back to face those errors we started with. Remember this guy? The name error? That message, name is not defined, isn't so mysterious anymore, is it? It's Python telling us, hey, you asked me to find the box with the label name on it, but I've looked everywhere and it just doesn't exist. It means we either forgot to create the variable or more likely, we just have a typo. It's a missing label problem, pure and simple. Next up, the type error. This error pops up when you try to do something with a type of data that just doesn't support that action. It's Python being the referee and saying, whoa, hold on. You can't divide a word by a number. That operation doesn't make sense for these types. It's a fundamental mismatch between the action and the data types, which goes right back to what we learned earlier. And finally, the attribute error. Think of this like trying to use the wrong tool for the job. Every data type comes with its own little toolbox of methods. The .lower method, for making text lowercase, is a tool that belongs in the string toolbox. Lists have a different set of tools. So when we try to use a string tool on our list, Python rightly says, nope, a list object doesn't have a tool called lower. So there we have it. We started with what looked like cryptic nonsense, and now we have clarity. Let's just quickly recap how these core ideas really do change you from someone who just writes code into a confident problem solver. These are the key takeaways. First, always remember, variables are just labels. Second, an object's type defines its rulebook, what it can and can't do. Third, constantly ask yourself this one question. Is this data I'm working with mutable or immutable? Just asking that will prevent so many future bugs. And finally, write code for humans using snake case. With these ideas in your head, debugging is no longer a random guess. It's a logical investigation. So I'll leave you with this to think about. The next time you sit down to write some code, and especially the next time you see that wall of red error text, how will understanding these fundamental rules, the rules behind the code, change your approach? Because you don't just see an error anymore. Now you see a clue.